Yeah, so this is the instruction for the Docker that I put on the team. If you go to file, under file, you'll see there. Mm, you have to post. Yeah, so yeah, then I also another thing, I'm creating a repo for most of the scripts uh that we're working on. Let me see. Um where's this? Okay. Yeah, so I'm creating the repo now. So if you can see my distance, so I've only added Ansible code there. So I will put Terraform, those Jenkins file that we did. So I'll put them in the repo so that, you can take a look directly. You can do Git clone, again, you don't have to push to my repo, where you can take a look or maybe copy some stuff you want to. If you notice, this was the one that we used the last class for Ansible. So if you just want to make reference or just copy stuff or just clone, make a clone. This is the HTML template that we use. So yeah, I will be putting everything. I created a folder. This is the repo right here. So I created a folder for Ansible Lab. So I'll be creating more for like Terraform, Jenkins, and stuff like that. So that we can, even after the class you are trying to practice or make reference to stuff, you'll be able to, you can do that. uh, yeah. Today we'll be looking into Docker again. Docker, it's a very popular tool in DevOps world, and we're going to look at what a container is and stuff like that. So this will be our agenda today. We're going to talk about monolithic application, microservices, container technology. Then we're going to do introduction to Docker, Docker container, Docker images, some commands in Docker that we're just going to play with. But again, some things especially the word monolithic. Maybe some of you have heard some of all those things before. Indeed, it's very big. Those are like the basis of DevOps. Microservices, especially which allow things to work and scale. We're going to see what all these things are. So for monolithic application, basically in software engineering, monolithic, just like the name mono one, if you remember our high school grammar and stuff like that. So a monolithic application describes a single tiered software application in which the user interface, the data access code are combined into a single program from a single platform. So as you can imagine, given their broad scope, monolithic tool tends to have huge code base. So basically, again, so far in this class, most of the like application code we've been using are very basic HTML and stuff like that. In the real world, again, this people works with a lot of code line, a lot. We're talking of thousands, in most cases, and maybe an application like Uber, Netflix, all those stuff, I'm sure they have hundreds of thousands of line of code. So yeah, it's very huge, very huge. So monolithic, it's a way where they write the application, they write the code. Again, it's not you writing this code. I'm talking of software code now, the code that does the work itself, not a CI/CD code or a Terraform code. No, the code, the application code itself. So putting that everything together, in a bunch, very huge, like 200,000 and stuff like that, that is monolithic. It's just in a single code base in a Git repository, one line one to this thing, that is the whole application. So that's how software, more like legacy way of software application development, like the old school. Again, I'm not saying a lot of companies still use monolithic up to now, depending on the size of the company and some of their how advanced they can be. But it's becoming like old school method of doing application these days. So because again, you have so many lines of code, 100,000 or even 10,000. Imagine how long it takes if there's error in just one part of the code, it brings the whole application down completely. Everything will be down. So imagine if you are trying to build it maybe through Jenkins, that will literally take maybe 30 minutes to run, and if it fail again, it's a lot. Trust me, especially if you are working in a large environment like that. So that is monolithic, and we are going to see the opposite one, which is microservices, and which is the one that it's most scalable and a best way to not a best way, like a better way to address this monolithic this thing. Then we're going to see some problem with monolithic. So what are the challenges with monolithic? Again, monolithic is just having your code in just a single line, just not a single line, just a single repo or whatever in a single source, just one place. So again, it's difficult to scale. You want to scale, just means that, okay, you want to, maybe you're getting too much traffic on your website, uh, you want to add another server and stuff like that. It's difficult to scale monolithic application. It takes time to build and test, just like I said before. Maybe you are building, just like you see in our Jenkins, we build the application. Again, the application we're building with Jenkins in this class is, it's just a low word application, very like a few lines of code. So again, the real world, we're talking of thousands of lines. So that takes a lot of time to build and to test, on the distance. So another one is difficult to debug or troubleshoot. Debug is like, trying to find error problem within the code. When you have, most of you used to get error when you run some code and stuff like that, it will fail or this thing, then you start checking what goes wrong. That's debugging. Now, if you have so much lines of code like that, where do you start? Maybe line 1040. That's where you see, it's a lot. So another one problem is the application is too large and complex to fully understand and make changes. It's too large, too complex, and and making changes takes time. So then you must redeploy the entire application on each update. So on each update you do, just like when we are doing update on our Jenkins that time, then it will trigger Jenkins, we make an update on the code. So each time you do update like that, we do everything, literally run everything from up to down. Maybe you only change one line in line 2005 on the code, then it would literally run through everything from A to Z again, all over. It's a problem. It's not really, again, when you're working the large scale, like maybe Uber and stuff like that, and all those big tech, it's there's no way they can really survive with that. So then let's see what microservices is, which is again like opposite, just like micro. You know what micro is? Smaller things, and this. So microservices are a method of developing software application which are made up of independent deployable modular services. Each microservice runs a unique process and communicates through a well-defined lightweight mechanism such as container and stuff like that. So basically, let's take a look at this diagram, which I think do a bit justice to microservices. Again, this is like online shopping service, like maybe Amazon.com, Walmart.com, or any e-commerce you can think of. So in microservices now, they will have everything separated, different code. All these things are different services, independent. So for example, account service, you want to create account and stuff like that. It will be a separate, it will be on a separate code, maybe different Git repository that we have that code completely independent of the other one, but they will have a way to communicate to like the central ones, whereby, for example, product category have to communicate with this, carts, when you want to check out, you put your item in the cart, it will be a separate code that will be handling that. Then other service too, placing order, some company maybe people searching for orders, that will also be a microservice on their own. So they separate the code. The code is not like putting everything together. Now everything is separated differently. You see the database as well, every connected to it. They are completely independent. And the good thing this is that, you having junk of this. This is very basic. In some company they can have 100 of this, of their website separated like this. Again, at some point it become complicated because this one will try to talk to this one, this talk to this, but again they are completely isolated from each other. You can, so now for example, let's take this e-commerce for example, or this website for example, this online this thing. Maybe there's a problem in the in account service for example. It doesn't stop other service from working. People will still be able to place order. People will still be able to put a item in their carts. People will still be able to check products. Maybe temporarily the account service, you can't create accounts. That would be the only one that will be affected, in this case, because everything has been separated and it will not really affect other ones. Other ones can still be worked until maybe you're able to bring this account service up. I'm sure in some cases you might have noticed in some website like that, other this thing will work, but maybe when you click on specific parts of this thing, maybe you try to create account, maybe at that time that's what will throw you error. But you can click on any other thing, it will work. You can go to the home page, it will work. You can go to maybe create whatever, it will work. But maybe you are just trying to do some other things, then that's why. So those are microservices. And if they are not microservices, if they are just a single bunch of application, it will, if one of the this thing is down, everything will be down. If just a few lines of code has a problem, the whole platform will be out. So microservice is very huge, very huge in the industry. And again, container is the center of that. It allows you to do the isolation, to like separate things, and they talk together. And that's where stuff like Kubernetes comes in, because again, this company, most of them have like hundreds of all these microservices, each talking to each other. So it becomes a very big problem for managing them, networking. Maybe the account service will have to talk to cards, but the cards doesn't have to talk to this, back and forth. You have to, the ports that will be open on each of them and so on. So it becomes this thing. But again, this is the basic microservices explanation I can give. And compared to like monolithic kind of application, this is better scalable. And another interesting thing is that you can, for example, maybe on the website now, people, maybe you have a product catalog. This is where most of the traffic comes. Most people visit this. Of course, people in most e-commerce, this thing, people search item more. For example, they can have a microservices for searching item. So searching item, that would draw more traffic than anyone. People will search item, but not everyone that search item will place order, will do order, or maybe put the item in the cart. But the service, the searching of the item itself can be an application, a separate application on its own. So that's alone. Now you can scale it independently. If you notice that, okay, your this particular service has more traffic than the other one, has more people search more this thing than maybe placing order or creating an account and stuff like that. So you can be running this one, maybe 20 of search or product catalog. You can run 20 of these independently and run only 5 of these application, run 5 of these, run maybe 2 of these, because only a few people will create accounts at the same time. So, but maybe products, where people search for products, that is where most of your traffic goes. You can scale independently. You don't have to scale the whole application. You can scale the one that just like Uber. Uber, a lot of people search for ride. So their search services or application will be unique. I'm sure they will have a lot of container handling, searching. because a lot of people search for trip, but you end up not booking it at the long run. So there will be an application to book Uber. There'll be the one to make payments and everything. So, but not everyone that goes on Uber and search for ride for trip will end up placing order or going for the trip or whatever. So you can scale all those things independently without having to scale the whole application. If it is monolithic, you have to scale everything, because it's a single application that's running everything. So but again, microservices is very huge, and container is the center of it. Most of what this one will be container, 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 container. Then they'll be talking to each other, talking to this can be like API gateway or anything. So they'll be talking back and forth to them. Maybe this one will be coordinating the communication between them, that okay, you need to talk to this need to talk to this, and so on. So just I hope I'm able to just explain it a little bit. So why microservices? So why it is flexible, efficient approach to build and operate a software. Microservice architecture splits large application into much smaller pieces that exist independently of each other. Just like I explained, it breaks it down, and they can exist independently. You can scale them independently. Each microservices or piece of the application does one thing and does it well. So they focus on what they do. For example, the product, it will only be product code that will be there, and 100% focus on that. So again, this can be on different GitHub repository. This would be mostly, it used to be like that. So this would be, there'll be a GitHub repository they'll call product catalog. They will have a pipeline for that. Then they will have a pipeline for this as well to be in a separate GitHub. But within the code, there's a way they talk to one another. This one know where this is, and and stuff like that. So there's a lot of complexity goes into all those things. So microservice takes a significant amount of work. That is what goes into the build deployment and the updating the enterprise. So again, just understand what those things are, and it's very important and stuff. So using Uber as an example, from one article, you can Google microservice and at Uber, you see a lot of this thing, or at Netflix. Those are like the main people that use all those things very well, like because they have so many services, so many things that they are global services. They have too many traffic. There's no way they can have the application running on a single application, on a single code. So no way, So those people use container, use all these Kubernetes heavily, to separate their services, their this thing one from another. Those Airbnb, name some of those companies. From end user perspective, you wouldn't know what is going on in the background, but trust me, it's a lot of this thing. There's a lot of complexity going on there. So if you see, this was how Uber started off, just nothing else. They have everything. You see this hexagon or whatever. So everything is within that. They have the user, just interacting with it. But at the point they couldn't cope with that, they become global service. There's no way they could maintain every. This is location, this is notification, this is payments, everything within the same distance. So this is the new one. This is like the latest kind of architecture they have. You see billing here separated. Payment is a separate application. Notification is a separate application. Trip management, driver for Uber, everything is separate, but they talk to each other. You see all this line connecting them. This talk to this talk to that. That's what stuff like Kubernetes can help you manage, all those communication within each of these services, which they call them services or, application or whatever. So, these are just basic. It's way more complicated than this. And, this is how microservices at Ubers look like. Everything, it's in different application. So for example, if you may not be able to make payments at some point. I remember when I was doing Uber, drive Uber, there are sometimes, the Uber application will still be working, but they will you try to like cash out your money, it will give you an error that there's a problem, that they are working on that, and you can't literally take out money. This is because this is a microservices. They have a separate application dealing with payment, dealing with taking out money from their application. So it doesn't affect. I can still make trip, I can still accept trip, I can still do everything, every other thing, but I cannot just take out my money out temporarily. Of course, I was still able to do that. But so that's the beauty of microservices. It will not affect the whole application completely. It's not like you'll be down completely. But if you are monolithic, if such problem happen, you'll be completely off the mark. You won't be able to do anything on the stuff. So again, just good to know. So we talk about container technology. Container are a form of operating system virtualization. A single container might be used to run anything from a small microservices software process to a large application. Inside the container are the necessary executable binary code, library, and configuration file. So basically, container is just like the name, a container which just package the application and just run it like that in a lightweight version. So now what we've been doing in the class so far, we put our jar file, just deploy it into Tomcat and stuff like that. Tomcat is running on our Linux machine directly. Tomcat was running on our Ubuntu machine. We push our this thing there. So, in that case now we can literally have only one application running in that machine. So what happened is that if you want another Tomcat application to run together with the one we have to bring up another Ubuntu server. So, and this thing basically, what your application needs to run, it's just basic thing. It doesn't need a lot. You don't really need a complete server to host your application alone. Your application, what it needs is just a very few stuff, which they call dependency, some binary library and stuff like that. So container will allow you to do that and kind of like give you the minimum things you need to run your application, as small as possible. And that way you save a lot of space. You don't have to like run one application on one server. That way now you can, on my computer, I can have 20 application running on this thing, because one, they are lightweight and they are isolated from each other. That's what container does. It kind of like contain, just package it, kind of like package the applications and put all the dependency, the library, everything together, bulk them together. Because again, for every application to work, they need all those dependencies. I mean, talking of real application, they have so many what they call dependency, library, not just the code itself. There are so many things that has to be bundled together for an application to become what will be running. So container give you that opportunity to like just create a small space that will give you that necessary thing, that basic necessary thing, and to run your application is lightweight and stuff like that. Then yeah, hello.
No.
Oh, okay. Yeah. So another similar technology to that. Another similar technology to that is what they call virtualization. VirtualBox. I'm sure some of you are familiar with VirtualBox, which I think I use it at some point in this class. So the VirtualBox is still different, which is something we're still going to talk about. I want to, as much as possible, try to understand the difference between virtualization and container. They are different, kind of similar in what they do in terms of like isolating things and allowing you to run multiple stuff on your machine rather than just wasting your space and stuff like that. So I put this thing, we're going to talk briefly about the differences and what virtualization is. Again, it's different, and just understand what container is at the high level. It just give you that minimum minimum space or container, kind of like container to like package your application and run it, which is very lightweighted. It allows you to run a lot of them on a single host machine. So we're going to see what's a container include. It include the code. Again, the code it's not the only thing that makes up the application, the configuration, the process, networking, dependencies, because sometimes dependent networking is how they talk to one another, and stuff like that. Just like your machine, your laptop, or this thing, they have some networking in between inside them, like all those IP address that we are. This allow them to talk to the outside world, the port, and all those stuff. So those are networking which allow container or this thing to talk to each other. So container just have minimum of all this, very minimal. You don't need extra things. On your computer, you have a lot of things you don't really need to run an application. On your operating system, you have so many things you don't really need. If you are running an application, you don't need a lot of things you have on your operating system. They are just taking the space there, and so to run an application, there are just some bare minimal things you need. Container allow you to just grab those and just pack them together with your code and run them in the make them to run. So again, that gives you opportunity to run many. You can run 10, 20 containers which are application on the same machine. They will be isolated from each other. If you want them to talk to one another, the way it completely distinct. Whereas if you don't have a container, the way you can do that is to have a what they call maybe virtualization, which again is not it's not as good as a container. So virtualization, let's see what it looks like. Again, some of you might be familiar with it. It's a process of running a virtual instance of a computer system in a layer abstracted from the actual hardware. Most commonly, it refers to running multiple operating systems on a computer system simultaneously. This second one kind of very summarize it very well. So virtualization allow you to run multiple operating system on your computer. Again, the common one people use is all these virtual box. There are a lot of them like Hyper-V by Microsoft. VirtualBox is mostly for user in organization. They use the what's the name of that one? So but you can have that on your machine. The VirtualBox will be there, which they call the what they call it again, the hypervisor this. So the VirtualBox will be there. It's an hypervisor. So you need to have that before you can have a virtualization. Again, virtualization, you have your computer. Let's talk about your computer, Windows computer, most of you, or Mac, some of us. So you have, that's what they call operating system running on your hardware. So on your hardware, you have operating system installed on it. So on that operating system, you install what they call a hypervisor. Hypervisor can be VirtualBox or the other one, which they call Hyper-V or something like that. So it could be this VirtualBox. It's also it's an hypervisor, but you have to install it. So on the VirtualBox, so on the VirtualBox, that's where you now install all those operating systems. So you can install various operating systems on the VirtualBox, like Ubuntu. Even if you are running Windows, you can install Ubuntu on that, and you can install any operating system, even Mac OS. But it's taking it's taking your space, the space of the host hardware. It's taking so many resources on your RAM and everything. So if your computer is not if you don't have a very high capacity, like the good RAM and stuff like that, this can slow down your computer completely. So but that's VirtualBox, and it's very common in the industry too, at some point, and but stuff like containers taking over, because VirtualBox has some limitation as well, which we are going to see briefly, especially the difference between virtualization and container, because those two are very close in terms of what they do. But we're going to see what with this diagram. If you go online, mostly this is what you see a lot in most of the diagram. So I will try and explain it as much as possible. Again, this is your machine. Let's talk about your computer. We're talking about the one on the left now. This is container. This is virtual machine. So you have your computer running. So on your computer, you have operating system, of course. So on that operating system, you install a hypervisor, which could be a virtual box. So on hypervisor, you now install guest operating system like Ubuntu, like maybe CentOS, Mac or whatever. You can do that on those hypervisor. Again, hypervisor can be virtual box, which is very common, especially to users like us. So you can put all these things there and you can log in, run them. So on those operating system, again, for example, I'm talking of industry now, they now want to run their application on each of them. So they can only run one application on each operating system. So maybe they have Linux here, maybe they have Ubuntu here on their virtual box. They are running their application on this. So just a single application they can run there. Here too, they can do the same thing. So there's a lot of space wasting. Maybe this guest OS, this one, the green one here, have about 2 gig RAM that you assign to it. The application itself may not be taking more than maybe 500 megabytes or maybe 200 megabytes to be running. But again, you can only run one version of this at a time on this operating system. Same thing with this operating system. You are still wasting a lot of space doing this. Another thing you can do is to create more operating system, more guest OS. So this is how a virtualization works. You have to install operating system on that hypervisor. So for container now, you don't have to do that. Just have a container engine running. Then on top of the container, you don't need to have a guest operating system like this. On top of the container, that's where you install the application directly. So you run the application, which will be a container application, in this case, directly on your operating system, which will have a container, this thing like Docker engine or whatever. So, but just understand someone, even before I get the concept, it took me some time, just take a look again, maybe do some reading, research or whatever, just understand some the difference. But again, I think this is how maybe when we get to the lab part again, you see some of all those things. But again, this is virtualization and this is container, and this is the main difference. Here you still have to have the guest operating system that before you put all those your application. In this case, you don't have to install any operating system. So directly you can put your application, Docker application running, or any container application that you have. So then VM contain a full copies of an operating system. This like a complete copy of operating system you are seeing here. Again, there are so many spaces wasting. You don't really need a lot of what is inside an operating system to run your application. You don't need a lot of them. You only need very bare minimum stuff to run it. So the application, necessary binary and stuff. So it's taking a lot of space, and it's not the best practice. So let's talk about Docker, which is a container tool, which is like by far the most popular one. There are other ones as well, but Docker is the most popular one, and again, you don't really need to worry about this thing. So Docker is a set of platform as a service product that use OS level virtualization to deliver software in packages called container. Again, like I said, it package those software in what they call a container. So Docker is an open source project that makes it easy to create container and stuff like that. It's open source, it's free to use. You can sign in and stuff like that. You can download it on your machine, run it, and yeah, you can sorry, you can download it and, run it and, create an application at a snap of the finger. So it's very, it's open source, it's free for everyone to use. And, we're going to see that. So we talk about container, again, a container is a standard unit of a software that package of code and its dependencies. So the application run quickly, reliably from one computing environment to another. So a container is a runnable instance of an image. We are going to see what an image is as well. But some of the question you can see is, okay, what's the difference between Docker container and Docker image? So Docker, a container is a runnable instance of an image. So you have an image first before you create a container from it. So when you run your image, that's when you get a container. So if you don't run image, you're not going to get a container. So the image is just like the, we're going to get to the definition after this. So a container runs on any machine that supports a container. And, it's one of the main thing with all these Docker container and stuff like that. Once you package your application like that inside the container, you containerize it and stuff like that, you can run it anywhere within any environment. It will be 100% efficient, work correctly, because work the same way. So far, that environment has a Docker engine that's running. So, I can create a Docker image now, a customized Docker image. Then I give you the link, you can pull it down, run it 100% to run the same way on your machine. And, it's very fast, and it allows that compatibility among any environment you are running it. It will run the same way, because so far you have a distance. So what's an image? So image consists of a collection of files that pack together all the necessary stuff like dependency and stuff like that. So the image is like the main thing that you create when you are like creating your application. So you create the image, then you store it, just like when we are building our application with Maven. Then we create this .wav file and stuff like that. Then we can deploy it to any environment and stuff like that. So when you can create image from that, create an image, that means you package it and you make it usable to run in any environment. So once you have that image like that, you push it to where they call Docker registry, which is Docker Hub. You can push it there, then from there you can pull it, run it in any place. Maybe you want Kubernetes to run it for you. We're going to see how we can create our image, which will be, I think, next class we're going to look into that. So, we can see how. But today we're just going to go with all the default image that we have in the Docker Hub. So another thing which you guys you have to create an account with Docker Hub. So I will show you what a Docker Hub is. Then so just understand images and stuff like that. Let me go to this thing and just say Docker Hub. So Docker Hub. So if you go into Docker Hub now, you see stuff like this. Let me sign out. So Docker, just like your GitHub account and stuff like that. So it's a repository where they store image. So you can create an image, you put it in the Docker Hub. Then if you want to use it anytime in the future, or so in organization they used to have a Docker Hub like that, which would be like a central place they store their. Once they write their code, they will Dockerize it. They call it Dockerizing. That means they will package it, use the Docker to like contain the application, then they will push it to like Docker Hub. Just like when we are pushing our WAV file to JFrog Artifactory, we push the WAV file there, then anybody can pull the WAV file and run it in any and do whatever they want to do. So Docker Hub is more like that. It's just like GitHub too, where you can put code and people can use the code, or maybe do anything with it, and pull and do everything. So Docker Hub too is very similar to that, and it's a very huge community. You see a lot of this thing there. If you want to attend this, I don't know if it will be free, but Yeah, and this is a Docker con. Let me see the pricing. Um, it's not even that bad. So, but, they used to have all this conference every year. Most of this, there's KubeCon too for Kubernetes, and there's a lot of them doing all this conference. So, but yeah, so Docker Hub is very. So I'm going to sign in. You can just create account. It's easy, free. If you do sign up, you have to have an ID, just like GitHub. Create an ID which will be unique. Put your email, your password, then just sign up. So it's very straightforward process to create account there. Unfortunately, I have an account, so I'm just going to sign into my account now. I think so. I think this is my fully. I still remember the password. Yeah. So this is how it looks like. Again, in your own case, you not see anything. For me, I've done some few things in the past with Docker, with Docker Hub, and these are images that I created. You remember very similar to GitHub. Let me show you my GitHub again. That you see GitHub to, you have your username / the repository, and then inside your repository is where you have your code and stuff like that. But again, GitHub is for code, not for image. But Docker Hub is for Docker image. All these are Docker image, and I can pull it down and they do different things with it. You see this, I've used this 270 times because I was doing one project on this. So, but again, I created this not too long when I was doing some demo. So, but you see some few, and I mean, in organization, they will have a lot of that, with tag. If I click on this now, you see you can tag it with different tag number, you see tag 54. So each time you push it, it will give you, it can update the tag every time. For example, you want to use a version of this, which may be different from this. So, maybe you make a change. If you make a change to your application and you build the image again, you push it to Docker Hub, then it will be 86. The latest one will be 86. Then, you can go back again, and then, you can give this URL directly to Kubernetes. If you want to like deploy it to Kubernetes, you can just use this for Kubernetes, and you will do that. Then you see some of the this thing which we are still going to look into, especially how to create a custom image and stuff like that. So, but this is Docker Hub, just create account for now, because I'm trying to, next class, we're probably going to still go back to our Jenkins, unfortunately. So, because it's very important thing to know how you can integrate Docker to Jenkins and push image directly. So when you build our application now, in this case, again, if you remember our Jenkins, when we build our application, we just do build, do the testing, SonarQube scanning, then we get a WAR file, then we deploy it to different environments, or deploy to maybe JFrog Artifactory, then from there put it to any. But now, after you build it, you can now Dockerize it, then you push it into GitHub like this. So it will be inside GitHub, it will be a Docker image. Then you can now use the image. So in some organization, they have it like that. So they build the application, run the test, do everything, package it in as a Docker image, then push it to a GitHub repo. So then it will be there. Then, when they now want to use it in another environment, when they want to run it, that's when you run a container. That's when they will now pull this out. Maybe they want to run it in Kubernetes or stuff like that. So I think it would be a good thing to do in the lab, which would be this thing. I would definitely put stuff together for that. And we're going to just Dockerize. It will be it will just be basically maybe 4 stages. It will not be a long pipeline. We're just going to have the application, the same application we use. Then we're going to test, we're going to do some testing. We may not even add SonarQube again, because I don't know if my SonarQube is still up. But we can just do this thing. Then we're going to integrate Docker into the Jenkins server. So Jenkins will build it. I will show how we can do that. So Jenkins will build the application through Docker. It will Dockerize it, what they call Dockerize, then it will push it to the repo. Then you will see each time it push it to the repository, it will be given it a new tag, like this, because this particular one, this is what I did, it was from Jenkins. So each time I build the application to give it a new tag, next one I build, it will give it a tag, because this I set it up to give it a tag directly from Jenkins build number. So if you remember Jenkins, each time you make a build, it will give it a number. You have a build number, build this thing. So I set my pipeline up that the tag should be the build number from Jenkins. So if Jenkins run another build now, it will be build 86 in that my Jenkins pipeline. Then the image will be tagged as that. So I can run this and do stuff like that. So again, let's see, let's just leave this for now. Then again, you can see public repositories as well, which you can search for any repository, like maybe which this we're going to play with Jenkins. You see 10 million plus download this official Jenkins, this thing. Maybe you want to use a Tomcat server, any application, you see the download. This is directly from their official image. You can just, if you click on it, you see they will give you where you can use it, Docker pool. Then all this installation that we are doing, everything is bundled into Docker image, and anybody can use it right now and just pull it. Then you have your Tomcat up and running. I'm sure if you watch some tutorial, they are running maybe their Jenkins on as a container. So this is how they do that. But you can also create a custom image too. These are like, these are image from the main people, like, you see all the popular ones, these are their image that it's public to everyone to use. You can use it, you can pull it, you can modify it and push it back there, do everything. So it's very important to, you see all the versions they have, they will give you some highlights on how you can use it, how you can run it, other stuff. So it's always like that. And you can think of anything, even Ubuntu, you see there, it has an image. But again, these are lightweight image. These are not real Ubuntu server running. These are very lightweighted and, just basic thing you need. So it will still be missing some things that your typical Ubuntu server has, so but that's why it's a container. They don't want a lot of things. Maybe you just need some very basic Ubuntu server. You don't want the whole operating system to be running. So you can just put this down, put your whatever you want to do on it and stuff like that. So there are a lot of them, any repo you want to, you can think of. Where do you see them again? Let me see the hub. No. I'm trying to see where to see all this repo organization. So, but again, you can search for anyone and do, again, all these are public. You can use it. If I give you the link, you can put down this image, run it, and see what is there. So then, let's install Docker on our environment and see how that works. So I'm signing in. So we're going to install it on Ubuntu server on AWS. Again, you can install it on your Windows or any environment, but this will be on Ubuntu, just so that we can just have a uniform distance. So I think I'm just going to install it from scratch. Then I'll call it Docker. The installation is very straightforward. Don't really need to. So let's use our Ubuntu machine. Then I'm just going to leave most of the settings as default. Then for the distance, I'm just going to, okay, I'm going to choose one of the, then I will launch it with this skip here. And then I'm going to give it a name, which will be Docker. So, it's just Ubuntu server, nothing nothing's there for now. So I don't have anything there now. I will just wait a little bit until it's running. I think we have a public IP address already. If I go to my terminal, can you see my terminal? I don't know if I'm showing it down.
Yeah, we can see.
Yeah.
Okay, thanks. Okay, I think it's running now. So I'll just use my SSH client. Then I'm just going to log into my uh, Refuse connection. Okay. Yeah, so okay, we were able to log in. If I do Docker now, you see it doesn't, Docker is not installed. So we're going to install Docker, and then again from this, I got it from the documentation, from all the stages or the process, and you don't, it's nothing to, but you must have the Docker running on your environment. So you first going to it's hiding this thing too. We're just updating our repo right here, and the next one will be to, I put this instruction too on our what's all this? Why is it adding this thing there? So then the next one would be to add this call command. I don't know. Let me do control here to take me to the beginner. Okay, that's okay. So the next one will be this. Hopefully it doesn't give me. Oh man. I'm gonna do control A again. Shit. I'm gonna do control A. I hope this thing works. I don't understand this. Yeah, then we're going to do sudo apt update. Apt update again. And then the last one will be apt cage. Sudo apt cage. This is sudo. Oh man, I don't know what's going on with this thing. So. Okay, I think a cage. Then there should be the last one now. Then we're going to install Docker finally. Wow. Command here. So command here. Yeah, okay. So now we are installing Docker. And by now we should have Docker running. Okay, I think we're good now. So if I do sudo docker -f version, we say we have a Docker distance. So let me just do Docker version. You see what is going to happen. Okay, yeah, it's running too. That's surprising. So if I do Docker PS, so Docker PS, you see you can run Docker command directly from here. So it has to, you have to do some other things to be able to run Docker. So if I now do sudo Docker PS, so Docker PS basically sudo we tell you list the images, sorry, the container that is running on your machine. So, right now we don't have anything. So every time we have to keep using this sudo to run Docker. You don't want to do that. So there's extra step to just take to avoid using Docker. You have to add a user called Docker. Then you have to add it to a group with Docker. Then that's it. Then you restart your system. So I'm just going to use this now. So if you don't do that, you have to be using sudo docker every time. So it said the Docker group already exists. Okay. So the next one is to add it. We created the group now. It said the group exists already. So we're just going to add the user. So we added the user now. So we go now, but we need to, so if right now, if I now say Docker PS, so it's still giving me that, but I need to like restart this. So if I exit, then log in again. So you need to like restart it so that I can implement the change. So if I say Docker PS now, it's good. It doesn't give me permission error again. So if you don't do that, every time you have to be doing sudo docker. So which you don't want to be doing that. So this Docker PS basically will give you the any running image. I think the PS is for process. I don't know, but basically that will show you the images that are sorry, the container that are running currently. So right now we don't have any container running, of course. We don't do. So to check if you have images, any images, you do Docker images like this. So it will show you all the images you have on your local repository. So right now we don't have any image, and that's why it's showing nothing. So we can pull an image and let's see what it does. So there's a simple image they call hello, I think hello world. So we can do Docker pull. Docker pull command will allow you to pull image. So if I say hello, I think it's word. This is not a makeup stuff I'm putting there. It's right on their repository. If it's not there, it's not going to work. So it's saying that okay. So it downloaded the image now. So again, if I go to my Git repository, sorry, to my Docker repository, and just search for hello world, you see there's an image with that name. You see this is the image I downloaded. I just downloaded on my machine. Hello world is just a very basic this thing. So I use the Docker pull here. So just to pull it. So let's see what we have on our this thing now. So if I do Docker PS, of course we don't have anything because it's just an image for now. So if I do Docker images, so it will show you the image. This is the name of the image and stuff like that. So you can have a lot of them. You see the size is a basic size. So let's make this a container. To make an image a container, you do Docker run. You run the image, then it will become a container. So here you can do Docker run, then the name of the image. So here it's hello world. So you can use the image ID too if you want. But here we have a nice name we can use. So hello world. So we are saying Docker run hello world. So this we run it now. You see it's run the image now and it exited. So that's what Docker does. It will run the image for you, then just leave you like that. So unless you want it to just run and stay. So let me clear my screen now and say Docker PS no this thing. So if I now say Docker PS-A, so it will tell you that we have a container. This is a container, So Docker PS will list a container for you. So -A, Docker PS will list a container that's running. But right now our container is not running. That's why we couldn't see anything when we run the Docker PS. But when we run Docker PS-A, it will show you all the container, both the one running and the one that's exited, that's not running. So that's just this thing to notice. And again, Docker images will show you the name of the image itself. So it's something you should take notes. So now we have a Docker image. Okay, let's say we want to remove our image or something. So we can say Docker let's say we want to remove our container. So Docker RM will remove a container for you. Then again, the name of the container right here is, what's the name of our container? This is the container ID. A container doesn't really have a name like that. So we only have a container ID. So we're just going to use the container ID. So we are saying Docker remove. So we want to remove the container. So if I do Docker ps-a now, it shows that we don't have anything again. So, but we still have the image. Again, you can run the image as many times as you want. It will keep creating a container for you. So if I run it again to create a new container. So let's say I now want to remove it. I say Docker RMI image, then the name of the image, which is hello world. Okay, latest is the tag. So hello world. I don't know. Okay, maybe I should remove the. So no search image. Hello world. Okay. I'm gonna do this. Hello world tab. RMI hello world. I think I think it removed it already. Let me do Docker images. Yeah, it's gone. So you remove it at this point. Yeah, deleted. Okay. So we don't have images, we don't have nothing again, no container on it. So again, you still be wondering that what's going on here. So let's see, again, you remember our Jenkins this thing. So let's search for Jenkins image and let's just run it directly from there. Again, if you watch some videos on all these things, that's how they use, and it tells you how quickly it is for you to bring up an application within a snap. So within any environment, you can just run all this command and guys, don't forget to put your stuff in mouth. Yeah, so now let's pull this Docker image and let's make use of it, and let's see what we can do with Jenkins image. So this Jenkins official image, instead of us going through all the stress of downloading the image, it's already downloaded. And next class we are going to see how we can create our own custom image. These are images that have been created, and this is what Docker file is for. So this Docker file, if I click on it, you see how they create the image. You see all the keyword from this, blah, blah, this argument, environment, they have a lot of what this thing run. So this is how the image was created. Again, you don't really have to worry about that for now, but, just good thing to know. You see a lot of people, there's a GitHub repository right now. So it's telling us how many people contributed to create the image. But again, the image is from Jenkins official website, official this thing. So, anybody can make use of it to run a Jenkins server. So, and again, every image they give you a customization, like a brief this thing on how to run it, on how to access it and stuff like that. So, so now we can basically do Docker pull to pull this image and say Docker pull Jenkins. So it's supposed to pull Jenkins image for us, then we can make use of it. So, but now it's asking for a tag. So let's see the tag we can use. So let's just use this tag 2.60.stream. I don't know, it doesn't do that before. I don't know, 2.60.stream. Because normally if you run that without putting a tag, they're supposed to pull the latest one. So then now it's asking for tag. So you see we are downloading stuff now. So this is the image you are downloading from the Docker hub, which is a repository. So it will download the image, then we can run it as a container. Then we have a Jenkins running. So again, it will take some time to. Yeah, that's it. So we have, if I do a less, you're not going to see anything. You have to do Docker images, then you are going to see that okay, we have a Jenkins image running. Then Jenkins image that we downloaded, it's not like running. Then this is the size and stuff like that. So now we can run it. Then when we run it, that's when we have a container, and that's when we have an application that we can access. So to run it again, if you go to this thing, they have, you can just use Docker run blah, blah, but you have to put the ports, you have to do some port mapping and stuff like that. So we can basically use this Docker run this and just run the container. I don't know why they open the port, but basically what this does is that it's just like saying Docker run Jenkins, but this minus P is just saying port number. If you remember, we use port 8080 for our Jenkins. So it's just saying open port 8080 within the container to outside. So if you are trying to access an application, you must open a port that you want to access it with. The 5,000, I don't know what the 5,000 does actually. So the 50,000, but the 8800 is the one we are going to use to access it. So if I run this now, again, it's still asking for the tag. So I think it's 2.60.3. So now we're running it and we should have a container. So you see, so basically we have our Jenkins server up and running. We just 2-click and a distance. So let's see if we can access our Jenkins server from here. This may also be fun. So again, you see it printed this passkey. If you remember when we are doing the installation, this is the key that we can make use of. So it put everything on the dashboard, and you have your Jenkins. You say Jenkins is fully Jenkins is fully up and running. So let's confirm that now. Okay, let's confirm that now. So again, we are just going to grab the IP address of our server. Again, it's running on our server. Let me see. Here's the IP address. Okay, the IP address, then port 8080. So port 8080. Then you see we have the Jenkins server running. Then if we go back to this thing again, then let me copy again. We are not trying to, but just to show you how quickly, how fast it is. With just the image, you have a Jenkins up and running, everything is good, and this thing. So I don't know, I couldn't install no such plugin. You see, this is a very lightweight Jenkins. So that's why I couldn't install all the plugins. I don't know why it's even doing this. Select. I couldn't even go past this actually. I don't know. No such plugin cloud B folder. Okay, but whatever. But again, we just have our Jenkins up and running. But let's say our terminal again. Again, you see it's running and it doesn't allow us to type anything again and stuff like that. So that's what containers does. It runs and you stop it. So if I do Control C now, it's going to terminate the container, and you will see the Jenkins server will be down. So I shut it down now. So if I refresh my Jenkins server, you see it to be unavailable because the container stopped. The image is still there, but the container and stuff. If I do Docker PS, you see we are not going to have anything. If I do Docker PS -A, so we still have the Jenkins container, but it's exited already. So you say exited 70 seconds ago. So if I do Docker images, we still have the image, of course, you can still run it anytime. So if you now want to run it in what they call detach mode, you now put -D. So if you do -D now, it will not just go off completely. So now you don't have to be stuck with the terminal. You can still view it directly now. So I should be able to view it now again. So it's in a detached mode. So it's in a detached mode now. So I'm not stuck with the terminal. So if I do Docker PS, you see that it's running. So you see it's up and running. It's not hesitate. It's saying port this to this. It's open to everyone. Then we have another port for 50,000 that's open. This is the name, this is the command, whatever, a lot of stuff. So, then you can remove it, delete it and stuff like that. That's how to bring up a container. That's how to, then I can say Docker stop. Maybe if I want to stop the container, then I'll provide the container ID. So You can stop it manually, so it stopped now. So again, my container should stop working. I can log into the container, which they call exec, just see what is inside the container. So again, just take it, just understand some of the basic, then, the integration is very important too, which we're going to do with Jenkins. We're going to integrate it, then we're going to deploy to Docker. You can run literally any application within a snap like that. And, it's a Docker that's running. In fact, the Jenkins we are using with my client now is running on Docker. Yeah, so some this thing prefer to just run it on Docker. And I can have another Docker, maybe Tomcat, running on the same Ubuntu machine that I use now, because it's lightweight, it doesn't take too much space, and they're isolated from one another. I can have another one running, maybe even a window-based application, to still be running on my Ubuntu, because it's sitting on top of Docker itself, not really on this thing. So I can start this thing again, and it will be up and running. I can check the log. You can do Docker log. The name of the Kubernetes is very similar to this too. I think logs. So to show you the log, what happened in all the process, you can still view your stuff here. So yeah, so there are a lot of command you can do. I can delete the image, the container. I can, if I do PS, you see we have the container run again. So it's Jenkins is there. Let me see. I think I have some of the command that I put here. The Docker run, Docker start, Docker stop, Docker build. Docker build is when you want to build your own image directly. So which you have to create what they call Docker file. We do Docker pull, Docker push. So basically now you can have an image, then you push it to a GitHub to a Docker hub repository, just like when we are pushing our code. So you do stuff like that. Before you do that, you have to do Docker login. So you have to do Docker login to log in into your Docker Hub account. So I'm Kenku23, then my password right there. So now I log in into my Docker distance, so I can do Docker push. Then I can push image to the repository, but I don't really have image I want to push right now. But let me see if I can push this image to my repo. Then I will have to name it differently actually if I want to push it. So I will have to name it, which I don't really. So when we create a custom image, that's when we're going to do that, because we have to give it a tag that we have a name that we have the same name with our username. So that way you see all this one have to have like Kenku slash something. So this is the name you have to give it, the name, the username slash the name of the repo, and then you can give it various tag wherever you want. So, but you can push things directly here, then you can pull it and do things with it. So yeah, it's very yeah, though it's those are then again, these are some of the command, these are containers command: create a container from image, start a container run, ls, inspect, log, stop, kill, remove, then build, push, docker ls to list image, history, inspect, whatever. So there are a lot of them, some of them are very popular, like PS, pull, push, the PS, Docker images is very popular too. You have to Docker run too. That's when you want to run an image to make a container. Those are just the basic one that we're just going to touch base on today. And next class, we're going to do a bit advanced stuff. We're going to look into Docker file, how to create a Docker file, then how to integrate it with Jenkins. We won't do too much things with Jenkins, just few stages, build and push it to Docker Hub. and then we're going to see how that works. Then again, take a look. Even myself, I won't lie. Before I understand the concept of Dockers, it took me time. So don't fear too bad or too overwhelmed. Like, okay, just take a look. Check out more stuff online. You think it can help again, add to your knowledge, and it's always like that. Different concepts. It's yeah, because trust me, those things can be very confusing sometimes. But again, with practice, learning, and stuff like that, um, I expect us to create a Docker Hub account before the next class, and they have Docker running. That probably if you can have your Jenkins running, maybe I don't want to I will use the Jenkins I have before. I don't want to use Jenkins from Docker because I've tried to use it. Sometimes I had a problem with that, which if I explain that, it might be a little bit complicated. Well, it's we're going to use one of the Jenkins. I think I still have one of the Jenkins running. So we're just going to integrate Docker with it. Then we're going to push image from there, create an image. You see how to write a Docker file. Docker file is very, very important. One of the most important things that I think if you don't know anything, you should know in Docker, what a Docker file is, some of the basic concepts, the keyword. It's really not, Docker file is not that hard. It's not like all this Ansible that we've been doing. It's very straightforward. Um, um, yeah. Any question, guys, with Docker? I know Docker is very straightforward.
Um, when you were creating the Docker, when you were installing the Docker, you created a user group, or the user group was already there.
Yeah.
And the user Docker, sorry,
Yeah.
the user, you use $, and then user. Is that
Yeah.
like a fixed stuff, or you can
Yeah,
or
it
you
is. It
can
is.
change it?
It
Okay, it's
is.
fixed.
Once
Okay.
you see dollar sign like that, it's a
Yeah,
variable.
yeah, it's
Yeah. So
variable.
if we do echo, let's see what that variable is now. Echo user, right? So it tell us Ubuntu. So basically, what they are doing there is that they are adding the Docker to they are adding that Docker group. Yeah, they are adding that username, which is Ubuntu, to the Docker group that we created. So if I log in with another user now, for example, I may not be able to run the Docker this thing, but now we added the Ubuntu user because this Ubuntu is a user. So we added the Ubuntu user to the Docker group that we created. At first, we created the Docker group. Then the second command basically added it, and that's why you see the $ user. So
Okay.
it's just saying you can basically substitute that with Ubuntu, but it's a variable that just let you don't have to think of the name. It's just telling you that the current user that's logged in. Yeah. Yeah, the current user that's logged in. So so again, you can substitute that command with the name of the user if you are 100% sure of the exact name. But that will give you that distance. But yeah, that's what it does.
Okay. So it's like the Docker, it's almost having the same concept with Podman for Red Hat, right?
Yeah, I think so. Podman I don't really know much about Podman. Podman, I don't really know much about Podman. Yeah, I think, I don't know. Yeah, probably. But pod, especially with Kubernetes, I know, container is more like a Kubernetes. It's more like a pod in Kubernetes. So yeah, container is more like pod in Kubernetes. But, that could be the same thing too with this thing. I really don't know. Yeah.